I'm now going to look at question 2 of the 2024 Further Statistics A-level paper. The question says, the number of errors made by a secretary is modeled by a Poisson distribution with mean of 2.4 per 100 words. Let's take a look how we go about doing this. And let's try and highlight the relevant part of the question that we need to pay attention to. So first of all, it's talking about Poisson distribution, mean of 2.4 per 100 words. So that per 100 words is important because part A is asking us for a 100-word piece of work, so we can retain that mean of 2.4. So let's look at part A, 1. Find the probability that there are exactly 3 errors. Why don't we call X the number of errors per 100 words? And from the question, we know that X follows a Poisson distribution with mean 2.4. Part A1 is asking us, what's the probability of X being 3? We know that for Poisson distribution, the probability of X equals X is X. E to the minus lambda, lambda to the power X, and X factorial. So we're using this formula, or we can use our calculator to work out. So this is equal to e to the minus 2.4 times 2.4 to the 3 over 3 factorial. Putting that into the calculator, we get 0.2090 dot 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 to 3 significant figures is 0.209. So that's our answer to part A1. For part A2, it's asking us for the probability that there are fewer than 2 errors. So that's the important thing is fewer than 2. So let's pay attention to our inequality sign. Fewer than 2 is not less than or equal to 2, it's less than 2. If X is less than 2, we simply are interested in the probability of X equals 0, which means no error. X equals 1. Oops. Or X equals 1. Try and be clearer. X equals 0 using PMF of Poisson distribution is e to the minus 2.4. This is simply 2.4 times e to the minus 2.4. So that equals 0.30844, which is roughly 0.308 to 3 significant figures. Now let's look at part 2b. After a long holiday, a randomly selected piece of work containing 250 words completed by the secretary is examined to see if the rate of errors has changed. So you see that I've highlighted 2 things here. One is 250 words. The other one is whether it has changed. Because sometimes when we test hypotheses, we might have to be testing whether, let's say, the rate has increased or decreased. And here is asking us whether it has changed. And therefore, we know that we need to be using a 2-tail test in our hypothesis testing. The other thing that we need to be paying attention to is the parameter. Because now we're looking at a piece of work containing 250 words. So what I'm going to do here is to call the variable y. So part B, y be the number of errors per 250 words. In a Poisson distribution, we're able to simply scale up the parameter or the mean. So if X follows Poisson distribution with mean 2.4, and that's for 100 words. So Y would follow a Poisson distribution with mean, let's call it lambda. Our null hypothesis is that lambda would be 2.4. Scale that up by 2.5. That equals 6. So our alternative hypothesis is simply lambda is here. Going back to the question, it's asking whether the rate of errors has changed, whether it doesn't equal 6. Let's look at our statistical tables. When lambda equals 6, so let's see which probabilities that we're interested in. Lambda equals 6. And we want to note down the probabilities that straddle 2.5 because we're looking at a two-tailed test. So we're going to be copying this probability and that probability, and also at the other end of the tail, that one, because these two probabilities straddle 0.975, which is 1 minus 0.025. So getting back to our question, based on the tables, so it's important to write these down so that we get points for our questions. For y less than or equal to 2 equals 0.0620, which is greater than 0.025. And probability, as we saw earlier, y less than or equal to 1 equals 0.0174, which is less than 0.025. Therefore, the lower end of the critical region is 1. At the other end of the table, y less than or equal to 10. Let's write these figures down. 9574. E of y less than or equal to 11 equals 0.9799. Therefore, we know that 1 minus e, this equals 1 minus 9574 equals 0.0426. And this is actually the same as probability of y being greater than or equal to 11. Similarly, looking at the tables, 9799, this gives us 0.0201. This is the same as the probability of y being greater than or equal to 12. So this is less than 0.05, and therefore C2 is 12. Therefore, the critical region is simply y less than or equal to 1 or y greater than or equal to 12. Now, part C is asking us for the type 1 error, probability of type 1 error for the test in part B. So part C, type 1 error, probability of it is the probability of rejecting H0 if H0 is true. So we simply want the probabilities that we had if H0 is true and y is less than or equal to 1, and if H0 is true and y is greater than or equal to 12. So we've got this from our plus 0.0201. This gives us 0.0375.